At this point, you have learned how to solve quadratic equations by factoring, using square roots, and completing the square. We're going to learn about another method, but first let's see how this other method was derived. We're going to take the standard form of the equation, ax squared plus bx plus c, and solve for x using completing the square. Now, something you should know about a, b, and c is that they are constants. They stand for a specific constant value, so they don't vary like x. But it doesn't matter what those constant values are. They're just some constant. If we can prove it's true for any constant, we can prove it's true for all constants. All right, so using completing the square, our first step would be to divide by the coefficient of x squared, or a. So we're going to divide all terms by a. All right, so that gives us x squared, the a's will cancel, excuse me, plus bax plus c over a equals 0. All right, so now we want to move the constant term. So a is a constant, c is a constant, so of course c divided by a is a constant. So we're going to subtract c divided by a from both sides. And I'm just going to write the x squared plus ba divided by x equals, and so we've subtracted c divided by a from both sides, so that means over here there would be a negative c divided by a, just to save a little bit of space. All right, now we need to add that magic number, b divided by 2 squared, to both sides. But what's b? Well, b is the coefficient on x, so that means that this is b, right? So b is equal to b divided by a. All right, so we're going to add b divided by a divided by 2 and then square it. Well, dividing by 2 is the same as multiplying by a half, right? So we're going to take, because we don't want to write this, right? We don't want to write that. So we're going to multiply by a half. And then we're going to square it. And that gives us, right, so we got to square the b, so that's b squared. Let's write the coefficient first. Right, so a times 2 is the same as 2a. 2 squared is 4, a squared is a squared. Right? So you can, when you have a product or quotient, you can distribute the exponent to all terms in the product or quotient. That doesn't work for addition, subtraction, just products and quotients. All right, so we're going to add b squared divided by 4a squared to both sides. So that gives us, I'm going to try and change the color of each step, so just make it stand out a little bit. So we have x squared plus b over ax plus b squared divided by 4a squared equals negative c divided by a plus b squared divided by 4a squared. Now on the left-hand side, we can now factor. All right, so when we factor, remember it's x plus b divided by 2 squared. What's b divided by 2? Well, it's this thing that you squared. Actually, I'm going to highlight it. So this right here is equal to b divided by 2, right? The thing we squared. All right? So we're going to, so when we factor, this is going to be, let's switch colors here. X, we have a plus, so that'll be a plus, and then that would be b divided by 2a, right? We usually put the coefficient first, so let me make that nicer. And that's all squared. Now we need to add those constant terms, but notice they don't have a common denominator. So we need to change the denominator so that they both match. If we look at our factors, we have a 4. We have a, so in the first fraction, negative c divided by a, we have an a. Right? In the second one, we have a 4 and an a squared. Well, a squared is just a times a, so I don't need this a. A squared's got that first a covered, right? So we need a 4, we need an a, and an a. All right, so 4a squared has got all of those things, but a is missing the factor of 4 and the factor of a. So if we want to make the denominator 4a squared, we're going to have to multiply the denominator by 4a. But if we multiply the denominator by 4a, we have to multiply the numerator by 4a. So over to the side here where it says simplify fraction, I have that over there, over all the steps there. So if we take negative c over a, looks like there's 2 negatives there. If we take negative c over a, and we want to change the denominator to 4a squared, we're going to have to multiply the denominator and the numerator by 4a. C times 4 times a, usually we put the variables in the letters in alphabetical order. A and c are actually constants, so technically we have just 3 constants we're multiplying. But we could write that as negative 4ac. And a times 4a would be 4a squared. So that's going to give us negative 4ac divided by 4a squared. Just what we have right here. Right? And we multiply the numerator and denominator by 4a. And then we have plus b squared divided by 4a squared. Now that they have the same denominator, we can combine those. So we still have x plus b divided by 2a. I'm going to just change the order, and I'm going to put the b squared first. That looks a little nicer to have the positive one first. So I'm going to put b squared minus 4ac divided by 4a squared. There we go. All right, now our next step is to take the square root of both sides. Right? So we have the square root of x plus b divided by 2a squared equals, don't forget plus or minus, because remember, all of these, a, b, and c, are just numbers. And when we take the square root, when we're solving for something squared, and we take the square root of the constant side, we need the plus or minus. Because whether you square something positive or you square something negative, right, you're still going to get the same thing. All right? When I write this, I'm going to just split this into 2 radicals because it's just a little easier. All right, so you can take a quotient and split that into 2 square roots. The square root of a quotient is the quotient of the square roots. You can't do that with addition and subtraction, but you can split it with multiplication and division. So in the numerator, we have the square root of b squared minus 4ac. In the denominator, we have the square root of 4a squared. Now the denominator is a perfect square. The numerator won't simplify at all, but the denominator will. Also, the x plus b divided by 2a all squared will simplify because the square and square root will cancel. So on the left, we have x plus b divided by 2a equals. On the right, we have plus or minus the square root of b squared minus 4ac. And 4a squared is a perfect square, so we can just take the square root. That would be 2a. Well, a couple last steps. Well, first of all, we need to solve for x, so we're going to have to subtract b divided by 2a from both sides. So that's going to give us x equals negative b divided by 2a plus or minus the square root of b squared minus 4ac divided by 2a. And I see I have fractions with a common denominator, so I could just combine those fractions as one fraction. Right? And that's going to give us x equals negative b plus or minus the square root of b squared minus 4ac all divided by 2a. And this is exactly how this formula was discovered. It was derived using just a, b, and c for the constants and solving using completing the square. Right? It's important whenever you use a formula that you know how it's derived and you know what it means. So for every formula we use, I'll show you that derivation so that you understand. Right? And now, I think we've seen this formula before because this formula is quadratic formula. Right? And that's exactly how that was developed. Right? It was derived using completing the square with the equation ax squared plus bx plus c. Right? So it literally quadratic formula literally comes from completing the square. So solving quadratic equations with the quadratic formula. The solutions of some quadratic equations are not rational or not real, and therefore cannot be obtained by factoring. For such equations, we can either use completing the square of the quadratic formula to solve for x and find the roots or x-intercepts of the parabola. So it's going to be an x-intercept if we have real solutions. If we have complex solutions, then it won't be an x-intercept. The quadratic formula is derived using ax squared plus bx plus c and completing the square. And I think you have that in your notes, and I know you have the formula in your notes. Right? So the reminder, the plus or minus symbol means the formula breaks into two parts. Right? We have negative b plus the square root of b squared minus 4ac divided by 2a, and negative b minus the square root of b squared minus 4ac divided by 2a. And that formula all came about just by using completing the square. Right? Something we actually already know. As we go through these problems, we're going to look at which. Sometimes it will be easier to use completing the square, and sometimes it'll be easier to use quadratic formula. And we'll talk about when it will be easier to use each technique. Let's use quadratic formula with this particular equation. And this one's in your notes. So 6x squared minus 7x minus 3 equals 0. All right, so we're going to use quadratic formula with this one. All right, you do not need to write quadratic formula again. You already have it in your notes. I don't have it on this page, so I'll write it. All right, so we have x is equal to, whoops. Let's try that again. I don't have my pen there. X is equal to negative b plus or minus the square root of b squared minus 4ac divided by 2a. And as we work with quadratic formula, I'll also alert you to common mistakes that students make, so we can try to help you, prevent you from making those exact same mistakes. All right, so we already have the values of a is the coefficient on x squared, b is the coefficient on x, and c, of course, is the constant. So now we have x is equal to, so that's negative b, so that's going to be a negative 7, plus or minus the square root of negative 7 squared minus 4 times 6, I don't know why I said c, 6 times negative 3. Notice I wrote a 6. Sometimes sometimes my hand's doing the right thing, my mouth says the wrong thing. And that's all divided by 2 times 6. All right, so that gives us x is equal to, the two negatives will cancel, 7 plus or minus the square root, negative 7 squared is 49. Be careful, there are two negatives there. So that's mistake number one that students sometimes make, is that they don't notice the two negative signs. So I'm just going to highlight those. And maybe that highlighter. And so right here and right here, those are two negatives. So that's going to end up being a positive. So just be on the lookout for those double negatives. So that's going to be plus, right? So 4 times 6 is 24. Plus 3 is going to be, or not plus 3, times 3 is going to be 72. Wait, did that too fast. 24 times 3 is going to be 72, yeah. I didn't trust myself. All divided by 12. So that's going to be 7 plus or minus 49 plus 72 would be 121 divided by 12. Now you're not done. So if you stop here, that's incorrect, because 121 is a perfect square. Right? And even if it wasn't a perfect square, if we could simplify, we still need to simplify it. So 121, square root of 121 is 11. I'm going to just move up to here because I'm running out of space there. I need to either write smaller. I don't know, quadratic formula takes up a bunch of space. So x is equal to 7 plus or minus the square root, is equal to plus or minus 11 divided by 12. And again, you're not done because we can combine that numerator. So don't leave it like this. So we have to split it. If you have numbers you can combine, if that was 7 plus or minus the square root of 11 divided by 12, that'd be fine. But we can combine 7 and 11. So we have 7 plus 11 divided by 12, and we have x equals 7 minus 11 divided by 12. So that's going to give us 18 divided by 12, which will simplify. They're both divisible by 6, so that would be 3 halves. 7 minus 11, that's negative 4 divided by 2, so that's negative 1, negative 2. Right, negative 4 divided by 2, yes, negative 2. All right, and those are our two solutions. Now, because we got rational solutions, that means that this was factorable. All right, so notice how many steps it took us to use the completing the square. We had to watch out for the double negatives. We had to remember to take the square root, and we had to break up the fraction and simplify. So you want to be able to identify the best technique for each equation. This one would have been a little easier to solve using factor by grouping. And let's take a look at that now. Let's solve this one more time, but this time factor by grouping. So again, A is 6, B is negative 7, C is negative 3. 6 times negative 3 gives negative 18. So we want two numbers that multiply to give us negative 18, but add to give us the B term of negative 7. And of course, that's going to be negative 9 and 2. Negative 9 times 2 is 18. Negative 9 plus 2 is negative 7. So we keep the 6x squared, and we change the negative 7x into a negative 9x and a positive 2x. And we keep the negative 3. And the first two are a group, and the second two are a group. Greatest common factor for 6x squared and 9x. They're both divisible by 3, and they both have an x. 6x squared divided by 3x is going to be 2x. Negative 9x divided by 3x is 3. The only common factor for 2x minus 3 is a 1, which is great because we have a matching set of binomials. They match. We can factor out that matching 2x minus 3, and we're left with 3x plus 1. And now let's solve. And I just realized I had an error on the last page. I dropped a number. So 2x minus 3 equals 0. Add 3 to both sides. 2x is 3. Divide by 2, and x equals 3 halves. 3x plus 1 equals 0. Subtract 1 from both sides. 3x is negative 1, and x is negative 1/3. So back here, I accidentally wrote a 2, not a 12, which would change my answer dramatically. So like I said, be very careful when you're using quadratic formula, because it's super easy to make a mistake like that, right? When you're just, simplifying numbers, write down the wrong number or forget to do a step, and it's going to change your answer, right? So 3 halves and negative 1/3, and notice we got the very same answers using factor by grouping, but this took us a little less time, right? And I think it's a little less prone to error when you can factor. So as we go through the problems, I am going to show you how you can know whether or not you can factor in an upcoming lesson. And as we look at problems that we can't factor, we're going to distinguish between which technique would be easier in this situation, completing the square or quadratic formula, so we always choose the easiest technique for the task. So thanks for watching, and bye for now.